This video is going to take a look at Lussac's law. The relationship for Lussac's law is between pressure and temperature. Our equation is P1 over T1 equals P2 over T2. So we're looking at how the temperature is going to affect the pressure of a gas. Let's take a look at the example that they gave us. It says that we have a 10-liter container of gas that has a temperature of 500 degrees Kelvin and it has a pressure of 100 kPa. So we need to pull the temperature and the pressure from that statement. The temperature was 500 degrees Kelvin. So that's going to be my T1. The pressure of that gas then was 100 kPa, and that will be my P1. Now, in this problem, they're saying that we want to reduce the pressure down to 20 kPa. So that's going to be my P2, reducing it down to 20 kPa. And then they're asking us, well, what temperature do we need to have that gas be at so we can have that pressure? So we're going to be solving for this T2. That's what we don't know. All right, so let's take the numbers, let's plug them into an equation, and let's solve for T2. So my equation was P1 over T1 equals P2 over T2. My P1 value was 100. My T1 value was 500. My P2 value was 20. And then my T2 value is what I need to solve for. So we're going to keep that as T2. That's what I want to solve for. The easiest way for us to solve for this T2 variable, I feel, is if we do cross multiplication. So again, we're going to multiply what's on top of this side across the equal sign to the bottom of this side here. So we're going to take the 100 and we're going to be multiplying it by the T2. So the top of this side to the bottom of this side. We'll do the same thing on the other side. The top, which is the 20, and we'll multiply it across the equal sign to the other side, which is the 500. So we'll have the 20, and we're multiplying it by the 500 on the other side of this equation here. That allows us to get everything kind of on one level, and we can do our math from here. So when we take a look, we can simplify this side of our equation because we have two numbers. So the 20 times the 500, it's going to give us 10,000 on that side of the equation. I can't simplify this down at all anymore because I have the variable on that side, the T2, so it's going to remain the same. If I want to get T2 all by itself, currently it's being multiplied by 100, so I need to do the opposite, which is divide by 100. So if I divide by 100 on this side, it will eliminate it from this side of the equation. If I divide by 100 on this side, because I did it on this side over here, I need to do the same, I'll be able to solve for T2. And my T2 will actually be 100, and the units for temperature in this problem would be Kelvin. When we take a look at this example here, we notice that the temperature went from 500 down to 100. And that caused the pressure to drop from 100 down to 20. So we saw that when we decreased the temperature, we saw a decrease in pressure. This is a direct relationship between these two variables. That will take care of the example for Lussac's law. Talk to your teacher if you have more questions.